Good evening, everyone. My name is Shravya from CSE section. Today's my topic is determination of X-ray diffraction due to powder method. Context of the presentation. Slide 3. Introduction. Slide 4. Principles. Slide 5. Why powder is used. Slide 6. Apparatus. Slide 7. Working of powder method. Slide 8. Interpretation of patterns. Slide 9. Debye skews method. Slide 10. Applications. Slide 11. Advantages and limitations. Slide 12. Precautions. Slide 13. Conclusion. Introduction. Powder extra diffraction is rapidly analytical technique used for identify crystalline material. It helps determine phase composition, crystal structure and unit cell dimensions. The material is taken finely powder form. The crystals are present in main random orientations. This change increases the change of some crystal planes will satisfy the diffraction condition. Principle. Powder extra diffraction is based on the Bragg's law. 2D sin theta is equals to n lambda, where theta is equals to interplanar spacing, theta is equals to angle of incidence, n is equals to order of diffraction, lambda is equals to wavelength of X-rays. Constructive interference occurs when reflected X-rays from successive crystal planes travels in phase at specific angles. Strong diffraction peaks are produced. Why powder is used? In a powder sample, a very large number of tiny crystals are oriented randomly. Because of these random orientations, some crystallines are always corrected alignedly to diffract X-rays. This makes the method suitable when a large single crystal is not available. It is especially useful for ceramic minerals, cements, crystals, and pharmaceutical powders. Apparatus. Main parts of a powder extra diffraction setup. X-ray tubes are radiation source. Filter are monochromatical to obtain near monochromatic X-rays. Sample holders are capillary tubes containing the powder specimen. Gonometer to control the angle between source and sample and detector. Detector to measure the diffraction beam intensity. Recording system or computer to plot intensity varies to theta. Working. The sample is dried, finely ground and placed in the holder. A beam of monochromatic X-rays is diffracted on the powder. Different sets of lattice planes diffract the X-rays at characteristic angle. The detector moves through a range of 2 theta values and record peak intensity. A diffraction pattern is obtained as a graph of intensity various diffraction angle. Each crystalline substance gives a unique diffraction pattern often called its fingerprint. It is the process of the diffraction of the X-rays due to powder method. Interpretation of pattern. The diffraction pattern contains peaks at specific 2 theta positions. From the peak position, interplanar spacing can be calculated using Bragg's law. From peak intensity, information about atomic arrangement and relative adjustments of phases can be obtained. Peak width can also give an idea about crystalline size and lattice strength. Debye method. The debye method is one of the oldest powder diffraction technique. It is in this method the powder specimen is filled in a thin capillary tube and exposed to the X-rays. Diffracted beam from a circular rings are photochromatic film or corresponding peak in modern detectors. This method is widely used for the fine powders and for polycrystalline materials. Determination of crystalline structure. Identify unknown crystalline compounds. Determining lattice parameters. Comparing experimental data with standard JCPDS or ICDD reference pattern. checking the purity of crystalline samples. Applications. There are a few important applications for powder extra diffraction method. Phase identification in material and mineralogically. Quality control in cement and ceramic industries. Identification of drugs and pharmaceutical components. Analysis of crystals, nanomaterials and semiconductors. Study of poison products and thin powder coatings. Detection of structural changes after the heat treatment. Advantages and limitations. There are few advantages and limitations. Simple and non-deconstructive technique requires only a small quantity of sample. Fast and reliable for crystalline phase identification, can provide structural and lattice information. These are the basic advantages of the process. Limitations: not very effective for the amateur material. Peak overlap can occur in complex mixtures. Preferred orientation may affect intensity values. Very low concentration phases may be difficult to detect. These are the few limitations. Precautions. When we are doing the experiment, these are the few precautions. The sample should be finely and uniformly powdered. The holder must be properly packed to avoid displacement at risk. Moisture and contamination should be prevented. Proper radiation safely measure must be allowed. Conclusion. Powder extra diffraction is an important technique for studying a crystalline material. It works on the basic Bragg's law and gives characteristic diffraction peaks for each substance. It is widely used in material science, chemistry, geology, metallurgy, and pharmaceutical. Thus, the powder extra diffraction is a powerful tool for the identification and structural analysis of the solids. Thank you.